Well, hello and welcome back to our AP Calculus AB summer video series. So today we're going to continue discussing limits. And just to review, let's look at this graph that I've drawn here of g of x. This is a piecewise function. And let's see what we can determine about this particular piecewise function. So we'll start with just a couple simple questions. What is g of 2? So when we ask what is g of 2, we mean when x equals 2, what is the y value, or what does g of x equal? So if we look at this graph, g of x would be 3. So how about g of 3? Again, when x equals 3, okay. Remember, when you're looking at a graph like this, the closed circle is what we're looking for. An open circle means it's not equal to that point. So here, g of 3 is equal to oops, it's not equal to that. G of 3 is equal to 2. G of 1? G of 1 is equal to 1. Okay. So let's look at some limits. What is the limit as x approaches 1 from the left? Okay, so if you remember, the way we notate that is we put a little minus sign in the upper right hand corner. So like where an exponent would go, we put a minus sign. That means to look at the x values coming from the left. So I'm coming from the left. What are the y values doing? So as x comes from the left, what's happening to y? So y is going up like this. And what is it approaching? Well, y is actually approaching 1. Okay, now how about the limit as x approaches 1 from the right of g of x? Well, what's happening with that one? So we're coming from the right, so we're coming from this direction, and we're getting closer and closer to 1. What's the y value doing? Well, this is all over here, and then here's y up here. But as I get close to 1, what's the y doing? It's actually approaching 1 again. Okay, so the limit as x approaches 1 from the left is equal to 1. The limit as x approaches 1 from the right is equal to 1. So since these are the same, they both equal 1, we can say that the limit as x approaches 1 is g of x, because it doesn't matter whether we come from the left or the right. The limit as x approaches 1 of g of x equals 1, because they are both the same. Okay? Okay, so let's look at the limit as x approaches 2 from the left of g of x. Well, what's happening? Get a thicker pen here. We're approaching 2 from the left, so we're coming from this direction. We're approaching 2. What is the y doing? Well, y is going up like this. It is also approaching 2. Well, let's look at the limit as x approaches 2 from the right of g of x. What's happening with that one? Well, x approaches 2 from the right, so we're going like that, right? X is 5, 4, 3, we're getting closer and closer to 2. What's the y doing? Well, again, my y's all over the place over here, but as I actually get close to 2 on the x-axis, y is getting closer and closer to 3. So, what is the limit as x approaches 2? Because from the left, we got 2. From the right, we got 3. They are not the same. Therefore, the limit does not exist. We write DNE, does not exist. The limit from the left must equal the limit from the right. Otherwise, the limit does not exist. It's as simple as that. Okay, so let's look at another one. Let's look at the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. And then tell me what the limit as x approaches 3 is. Okay, so go ahead and pause the video and try this by yourself. Okay, so the limit as x approaches 3 from the left, what's y doing? Y is approaching 3. The limit as x approaches 3 from the right, what's y doing? What's it getting closer to? 2. So what's the limit as x approaches 3? It does not exist. Okay? All right, so that's a good review. Let me just make up one more example here. I'm going to add a point to our graph. I'm going to add this point right here when x equals 4. Okay, so what is, oops, different pen here. What is f of 4? Well, f of 4 will equal 1. Okay, what is the limit as x approaches 4? Oops, I said f, I'm sorry. That should be g. Okay, what is the limit as x approaches 4 of g of x? Okay, in order to figure that out, I have to look at the limit as x approaches 4 from the left, and I have to look at the limit as x approaches 4 from the right. So as we approach 4 from the left, what does g of x approach? Looks to me like it's approaching 3. As x approaches 4 from the right, what's g of x doing? Now it is also approaching 3. So what is the limit as x approaches 4? 3. Now I gave you this example because I want you to see that the limit as x approaches 4 is 3, while the actual value of the function g of 4 is actually equal to 1. So the limit can be a completely different number than the function, right? So the function at that point is 4. But the limit is 3. Okay, so at this point we have discussed limits by looking at a table of values. We've looked at limits graphically. So now I'm going to show you how to determine a limit using properties, or what we might call algebraically. Okay, so if I have the limit as x approaches 3 of 1/2 x minus 7. Now this is a linear function, so I'm not going to worry about checking the left and the right limits, because a linear function, right, whatever's happening, it's going to continue in that same direction. So whatever's going on, if this is the point that I'm talking about, coming from the left and coming from the right, we're going to approach the same value. Okay, and the same thing happens with what we call continuous polynomials. Right, a continuous polynomial, maybe something going like this, right? Whatever's happening from the left will also be approaching the same value from the right. The only time that that is not the case is when we have some sort of jump in there, right? Something like this. Then we have something different. But when we're looking at a function, a linear function or a polynomial, we don't have to look at the left and the right. So all I'm going to do here is substitute in the value for x. It's really, really simple. So we're going to do 1/2 times 3 minus 7. That gives me 3/2 minus 7, or 3/2 minus 14/2, which gives me negative 11/2. The limit as x approaches 3 of 1/2 x minus 7 is negative 11/2. Okay. The limit as x approaches 2 of 6. So in other words, I could rewrite it, instead of saying of 6, to say, let's say the limit as x approaches 2 of f of x, and then f of x, we're going to say is just equal to 6. Let's think about what's actually happening there. F of x equals 6. Right? That is this line right here. That's the line y equals 6. Okay? Now, what's happening as x approaches 2? Here's my x approaches 2 right here. That would be the point there. What's our function doing? Well, as we approach 2 from the left, what's y approaching? 6. As we approach 2 from the right, what's y approaching? 6. This is a constant function. That means it remains constant. It doesn't change. So no matter what x value we're approaching, y is always going to approach 6. So this will equal 6. In fact, that's one of our properties. The limit as x approaches a of a constant function will always just be equal to that constant. Okay? All right, let's look at a little bit more difficult. Okay, here's one. The limit as x approaches 2 of 3x squared minus 4x over 5x cubed minus 36. So when we are evaluating limits, the simplest and most straightforward method will be to just do a direct substitution. So we're always going to try that first. it won't always work because sometimes we're going to have piecewise functions. Sometimes we'll have points of discontinuity. Sometimes we'll have points where it's undefined. But we're going to try to substitute first. And I believe it will work in this case. Right? So we're going to substitute in the 2. So 3 times 2 squared minus 4 times 2 over 5 times 2 to the 3rd minus 36. So that gives us 3 times 4 is 12 minus 8 over 5 times 8 minus 36. And that gives us 4 over 40 minus 36. So that's 4 over 4, which equals 1. So the limit as x approaches 2 of that function is 1. Okay, one more of this type of example. Let's look at the limit as x approaches 2 of the square root of 2x to the 3rd plus 9 plus 3x minus 1 over 4x plus 1. Okay, so what are we going to try to do first? Yeah, we're going to just try to substitute. Okay, so let's say this will equal, and that's not working, here we go. This will equal the square root of 2 times 2 to the 3rd plus 9 plus 3 times 2 minus 1 over 4 times 2 plus 1. So we get the square root of 2 times 8. So that gives me 16 plus 9 plus 6 minus 1 over 8 plus 1. So we get the square root of 25 plus 5 over 9. So that's 5 plus 5 over 9, which gives us 10 over 9. So there you go. Okay. Okay, let's move on to a little more challenging. So let's say that the limit as x approaches 2 of f of x is equal to 4, and the limit as x approaches 2 of g of x is equal to 5, and the limit as x approaches 2 of h of x is equal to 8. Now, I don't know what f of x is, or g of x is, or h of x is, and it doesn't matter for what we're going to do. We're just going to practice using the properties a little bit, okay? So let's see if we can figure out the limit as x approaches 2. And notice they're all approaching the same value, okay? The limit as x approaches 2 of f of x minus g of x divided by h of x. So this is actually going to use several properties, okay? So one of our properties says that when I have a rational expression, when I have a fraction, I can separate the numerator and the denominator. So I'm going to rewrite this as the limit as x approaches 2 of f of x minus g of x. And I'm going to divide that by the limit as x approaches 2 of h of x. Okay, so I took the limit and I separated those two as two separate limits. Okay, and then I'm going to apply another property. The limit as x approaches 2. So instead of writing f of x minus g of x, we're going to write the limit as x approaches 2 of f of x minus the limit as x approaches 2 of g of x divided by the limit as x approaches 2 of h of x. Right? Now, it feels like we're doing a lot of work that we shouldn't do, because you can kind of look at this, right? You're looking at this and you're saying, well, gee, just substituting these values. Yes, we will end up with the same answer. But part of what we have to learn in calculus this year is to show our work using correct calculus notation and vocabulary. Because on the free response questions on your AP exam, getting the right answer is not necessarily what we're always looking for. I know that sounds crazy. It's all the work that builds up to it. So a lot of times we know you can get the correct numerical answer, but you have to know what you're doing. Okay, so although we could get the correct numerical answer, you can probably look at this and right away tell me, or at least guess, what the correct numerical answer is. But why is this doing this? Okay, what I want you to be careful of, f of 2, right? F of 2 is not the same thing. It's not, I shouldn't say that. It is not always the same thing as the limit as x approaches 2. So I'm not asking you for f of 2 here, although the numeric value that we get if we find f of 2 is the same in this case. Let me say that again. The numeric value that we get if we found f of 2, right? It might be the same as the limit as x approaches 2. But in reality, we don't know what f of 2 is. Remember that example I gave you up here where g of 4 was 1, but the limit as x approaches 4 was 3, right? So I don't actually know what f of 2 is, right? So this is one of those cases where you could be incorrect with your approach, but end up with the correct answer. And we have to learn to be careful about that in calculus. Okay, we have to make sure that we actually follow the right steps and the right procedures. So I'm using my properties of limits to rewrite all of this. You see the difference. This was the limit as x approaches 2 of f of x minus g of x, right? Here, this is the limit as x approaches 2 of f of x minus the limit as x approaches 2 of g of x. And then we're going to divide that by the limit as x approaches 2 of h of x. So the properties say that I can rewrite this whole thing as separate limits. Okay? Now let's go ahead and evaluate it. The limit as x approaches 2 of f of x is equal to 4. Okay? We don't know, right? We don't know if f of 2 equals 4. We have no idea, because we don't know what f of x is. But we do know that the limit as x approaches 2 of f of x is equal to 4. Minus the limit as x approaches 2 of g of x, that equals 5. Divided by the limit as x approaches 2 of h of x, which equals 8. So we get -1/8. Again, I know some of you said, well, we could have gotten that right away with a whole lot less work. Yes, you could have gotten that, but you would have been doing it incorrectly. And that will lead to trouble later on. Okay? Okay, let me see if I can find one. Oh, let me give you a piecewise example before we stop. Let me check the time. Okay, just about right. All right, so let's say that we have f of x equals, we're going to make this a piecewise function, negative 2x plus 4 if x is less than or equal to 1, and it's going to equal the square root of x minus 1 if x is greater than 1. Okay, I want to find the limit as x approaches 1 from the left. Okay, now if it's approaching from the left, okay, so basically I have, let's see, when x equals 1, we get negative 2 plus 4, and that's 2, right? So I have a linear function. Okay, I have a linear function going that way, and then I have a radical, so let's see, 1, 0, right? So I have a radical that's going like that. So that's kind of what my function looks like. So I'm trying to figure out the limit as x approaches 1, right here, from the left. Well, if it's approaching from the left, then that means my x values are things like 0, negative 1, negative 2, right? So that means I'm looking at this particular function. So I'm going to do a direct substitution, but I'm going to use the top function. So this is going to equal negative 2 times 1 plus 4, which gives us 2. And that makes sense because if we're approaching from the left, then y is coming down here. It's approaching like that, okay? Well, let's look at the limit as x approaches 1 from the right. Well, if it's coming from the right, then that means the x's are greater than 1. So that means I need to use this function. So we're going to do a direct substitution, but we're going to use the square root of x minus 1. So it'll be 1 minus 1, square root of 0, which equals 0. So what's the limit as x approaches 1? It does not exist because the limit from the left does not equal the limit from the right. Okay, we're going to stop there. We're getting into some pretty fun stuff. There is a worksheet in the description section. There should be a link to a worksheet, and I think in the next video we will spend time going over that worksheet. If you have any questions, please email me, right? B. Murray at John Carroll. Oops, gotta move that out of the way. Right, johncarrollhigh.com. Okay? All right, see you in the next video.